Hello all, welcome to the pattern fraud prediction using imbalanced data. This is Sharath, and I'll be taking you through this pattern of giving you step-by-step instructions. This pattern is available at github.com/ibm/xgboost smooth detect fraud. In this pattern, we will demonstrate the methodology to build predictive system on imbalanced data. And the example we have selected is to identify fraudulent transactions in the financial institutions. This methodology can be applied to any domain to generate predictive models on imbalanced data. As we know, that credit card fraud is a growing problem worldwide, and it involves a lot of risk for financial institutions. We have selected this example to identify fraudulent transactions from the given number of transactions and help the financial institution mitigate the risk. In this pattern, the data set that we have selected is from Kaggle, and the number of fraudulent transactions is just 0.01% of the total number of transactions, which makes it very difficult for us to generate a predictive model with good accuracy because majority of the transactions are, legitimate transactions. After the reader has completed this pattern, they will understand how to build predictive models using bagging and boosting statistical techniques, and how to run different statistical models and evaluate the results, and how to sample the data to create a balance between the majority and minority populations to handle imbalanced data. We take you through different sampling techniques in this video, and we will also demonstrate how the sampling techniques can give a lift to the accuracy of the predictive model. I think this is one of the key things of this pattern. We now look at the architecture diagram. We see that we are using a CSV file, and we are loading that into object storage, and we will be using Watson Studio for doing all the statistical analysis. And after the file is loaded to object storage, we read it into the Jupyter notebook using Python programming language, and that is where we do all kinds of statistics on that particular data. And I will take you through the Jupyter notebook as well during this video. And after we run all the cells in the Jupyter notebook, we will evaluate the results and we will come to a conclusion as to how each model is performing and how the sampling of the data impacts the performance of the model. And the Jupyter notebook is powered by Apache Spark, which is under Watson Studio. As we can see the steps, user logs into Watson Studio, creates an instance, user uploads a CSV file, user imports a Jupyter notebook from the URL. We have already created the Jupyter notebook for you. You just have to import it from this repository. And the user will run the statistical model, which are in the Jupyter notebook. And user will export the predictive modeling results to object storage. The included components are IBM Watson Studio, which is used for data analysis and building predictive models, and it can give it can give interface of RStudio, Jupyter, and Python in a configured collaborative environment. We also have IBM Cloud Object Storage for handling the data, and we are using Jupyter Notebook, which is an open source web application, which is embedded within the Watson Studio. The featured technologies are data science, which is systems and scientific methods to analyze unstructured and structured data to extract insights. Analytics, which always delivers the value of data for enterprise. Python is the most sought after programming language for any kind of analysis on the data. Jupyter Notebook is one of the favored IDEs, the integrated development environment, to work for when we are using Python programming language. Now let's look at the steps to run this code pattern. First, we need to sign up for IBM Cloud. Once we sign up, we get a free 30-day trial account, and then we can sign up for Watson Studio by following the instructions here. And once we create an instance, we will get an object storage as well. We'll be using the cloud object storage for this pattern. We also need to create a notebook under the Watson Studio instance. As you follow the instructions, we just have to click on create notebook and then select from URL and then give a name to the notebook, and enter this URL there, and then select the runtime as per the computation, and then click on create button as per the instruction. And then the fourth step is to add the data. We just need to look for the 10.1 icon, and then hit that, and then select files, and then browse, and select the data files from the file system of the computer and add it to the WhatsApp Studio instance. As we can see that the dataset has been downloaded from kaggle.com credit card fraud data. The data file used in this pattern is a subset of original data, where we have selected 20% of random samples from the original data just to improve the computation power and to show the methodology. And then we have to insert the data in as data frame as per the instructions. You can just follow the instructions, and then the data frame will get inserted as pandas data frame. And then we have to run the notebook, and we have to run it from top down, where each cell is executed, and then it will go to the next cell, and we will be able to follow the results as well in the notebook. And then the last step is to analyze the results. We can evaluate statistical outputs in the season after each run of the model, and play around with hyperparameters for better results. We can sum up this whole process using the flow. We read the data, and then we sample the data, and the sample data is split into training data and testing data. And in training data, using training data, we are creating a classifier, which is nothing but different, statistical algorithms. And then we are using three statistical algorithms: random forest, and the gradient boosting, and extreme gradient boosting. Random forest comes under bagging technique. Gradient and extreme gradient boostings are boosting techniques, as the name suggests. And the classifier will create a predictive model, and output is generated, which is used for analysis. So the challenge is, while we are working on imbalanced data, there is no one-stop solution. However, in order to improve the accuracy, we can definitely work on different sampling techniques. SMOT is one of them, which is minority increasing synthetic minority increasing technique, where we increase the number of minority samples to strike a balance between majority and minority, and then try to build a predictive model. Bagging improves stability and accuracy of machine learning algorithm. Boosting is an ensemble technique, which is used to combine weak learners to create a strong learner, can make accurate predictions. Boosting techniques is used for stability, whereas bagging is used for accuracy. Now let's look at the notebook. I'll take you through a quick uh, overview of the notebook. So this is the notebook. You will find it in the repository. And as we can see in the first step, we are importing necessary packages, and we are reading the data and converting it into data frame as per the instructions. This would be the sample of the data that it looks like. We have like 31 columns, and we're assigning a new name for the data frame, because when we insert it as pandas data frame, it takes the name as df underscore data underscore 1, 2, or 3. We just have to rename it to df. And then we do some descriptive statistics on the data by selecting a few common variables, and then we'll see that what is the mean, standard deviation, and then the quartiles, 25%, 50%, 75% of the information for all the variables. This is just to get an idea of what is the maximum, what is the minimum, and so on and so forth. And we also get to see what is the standard deviation as well. We can also use histogram to visualize, how the data spread is happening in each variable. That's what we are trying to do here for different variables. We are doing visualization using histogram, and then we can see that the class variable is the variable that we are trying to predict. Out of the total of 57,874, 56 772 belongs to legitimate transactions, whereas 102 transactions belong to fraudulent. So this is definitely a case of imbalanced data where the number of fraudulent transactions is just 0.01%. And we're creating a histogram for all the variables just to check the spread of how each variable is. And then we are trying to plot fraudulent versus legitimate transactions on selected variables. These are just random selection. There is no reason behind that. As we can see that we are plotting the attributes V9 and V10, and then we are trying to see how much is the spread of fraud and non-fraud. And then again, we are doing the same for V16, V17, and a couple more variables. And here we are splitting the data into training and test set using 70-30 mix. This can be 60-40 or 80-20 or 70-30. We are just going ahead with 70-30. And then we are trying to use random forest algorithm as the first one, where the parameters are explained in detail as to what each hyperparameter does. And if after the model is run, we can see that we have achieved a F1 score of 87%. And the numbers might vary because of the stochastic nature of algorithms. Different runs will give different numbers for precision, recall, and F1 score. F1 score is nothing but harmonic mean of precision and recall. And then we go to the next algorithm, which is gradient boosting. This is again a boosting technique where we have explained the hyperparameters in detail. We have selected and configured hyperparameters to achieve maximum accuracy. And we see that the F1 score is lesser than what it was for random forest. And then we go ahead to the next one, which is extreme gradient boosting. This algorithm is very popular and is one of the leading algorithms to win Kaggle competitions. As you can see that we can do a lot of hyperparameter tuning, and we can use the model to build on the training data and test on the testing data. And we can see that we are hitting a F1 score of around 85%. It is definitely better than the gradient boosting algorithm, for sure. And we are moving ahead to select random variables for model building. In the earlier models, we had selected all the variables. Now we just want to go with fewer variables to see if there is an increase in the accuracy. So we have selected 6 variables, and we are running all the 3 algorithms again. We see that the accuracy is actually going down. So which means to say that fewer variables is not giving the lift in the accuracy. And moving to the next section, we are doing random undersampling, where we are taking 10% of the legitimate transactions and all the fraudulent transactions, and then we are merging it to minimize the gap between the majority and the minority populations. And we are again doing the split of 70-30, and we are running all the 3 models. We see that the accuracy is increasing by doing that. The more we strike a balance between majority and minority population, the higher will be the accuracy, is what we are seeing here. We can see that we are hitting almost 90% on all the algorithms. And finally, we come to the most popular technique, smooth synthetic minority oversampling technique. This is where we increase the minority samples to nx times, and then we try to model to see how would be the accuracy. And as you can see here, we are increasing the number of ones, which is fraudulent transactions, from 102 to 500. We are increasing it by 400%, just to give a balance between majority and minority transactions. And we are again doing the training test split of 70-30, and we are running all the 3 algorithms, and we can see that F1 score is going up to 95% in the random forest, and it is more than 92% in gradient boosting, and in the extreme gradient boosting, we are getting an accuracy of 95%. This shows that how important sampling technique is to build predictive models on imbalanced data, and how using different techniques like random undersampling and random oversampling and using SMORE can give a lift in accuracy using bagging and boosting algorithms. In this pattern, we have tried to demonstrate the methodology of selecting only three statistical algorithms, which comes under bagging and boosting, to show how do we strike a balance between accuracy and computation power. And then we will let the users to fork this repository and then use it for further development or enhancements, or to do any other development to suit the requirements. Please visit this repository at github.com/ibm/xgboot-smooth-detect-fraud for more details and documentations on this pattern. And if you have any issues running into this notebook or have any questions, just raise the issue under this repository and we will get back to you at the earliest. Thank you for watching. Have a nice day.